This is another set of stories from the trenches. I've actually been teaching introductory statistics at the university for over 40 years, so I've seen a translation from the way we used to do it with chalk and a chalkboard and to the use of computers. And what I'd like to do is to talk about some of the problems that have evolved as the teaching of statistics has evolved. One of the things that has happened is in statistics is there are a number of statistical packages that are available for solving statistical problems. And the result of that has been both good and bad. The bad part is that students do not understand the concepts that are involved in the use of these packages and simply use them rotely. And as a reviewer for several scientific journals, I am appalled at the number of misuses of statistics that have occurred in my discipline. So this is a question of providing hands-on problem-solving experience. Now, as educators, most of us will agree, one of the best ways to acquire statistical knowledge and skills is to engage the student in problem-solving exercises. The traditional approach has been to assign homework problems, and the student is expected to work on these problems alone or in a study group and return the answers to the professor, who at some later point grades and returns the assignment. And since my classes have grown over a 40-year period from 20 students to 300 students, the later became very much later, okay? There are a number of shortcomings of the traditional approach. The first is errors are typically not detected by the student at the time at which they occur. These are both clerical and conceptual errors, and they tend to cascade, leading to some catastrophic failures in understanding on the part of the student. Feedback is typically so delayed that it's totally ineffective, and as a result, students often copy the work of other students, and that doesn't improve the learning experience in any way. And then the class sizes have grown so large that universities often don't have the resources to even grade such assignments, and that's certainly true in our course. Now, one solution to these difficulties is to have a statistics tutor immediately available to the student when he or she is working on an assignment. And that's probably the optimal solution. If you have somebody who understands statistics, you can have a problem that the student has to solve. If they run into difficulties, you have a tutor right there to help them with it. The tutor can detect errors when they occur, distinguish between clerical and conceptual errors, help the student correct her or his misconceptions on the spot, and identify weaknesses in the student's understanding and suggest how they can be corrected. In other words, the student can reap the benefits of problem-oriented learning, especially if you have a nice, well-skilled tutor available. Now, computer-based instruction can detect errors as they occur, so that's one thing they can do. And it is possible to distinguish among some classes of errors, but not anywhere near as well as a knowledgeable tutor, so that's one limitation. It can provide hints that will help the student correct his or her misconceptions online, and in case of persistent understanding, provide students with supplemental tutorials or reading at the time at which they're engaged in the exercise. So, in addition, these computer-based homework assignments can also do some other things. They can allow the students to work on the assignment anywhere in the world, provided that there is an internet connection. So that's a real advantage. You can take it home. You can take a break, you can go away and come back and do it. It provides immediate feedback to the student, and as a psychologist, we've all long known that immediate feedback is a good thing to find out when you're making a mistake or not. And it provides a complete step-by-step record of the student's progress on the assignment. So if you're reviewing it later, if the student doesn't understand something, then you actually have an idea of what mistakes they made. And importantly, from the point of view of having 300 students, it can automatically grade the homework assignment. And what I typically do is let students work on it as long as they want to, and to repeat it, and they get the best grade possible that they can get. So, and it sends an encrypted grade automatically to the instructor, so it eliminates a lot of work on the part of the instructor. And in addition, it can provide supportive interactive tools to help the student better understand the concepts. For example, finding areas under a probability density function. Providing some help, one of the difficult concepts students have, especially the students I teach who have very little in the way of mathematical preparation, and really do not want to take statistics at all, it's a required course in the social sciences, is to get them to understand some of the concepts. If you can present the concept in a way that is intuitively obvious by using a pointer to change the area under a curve and indicate it, it works out a lot better than if you don't do so. And this is an example of a problem. You can have a problem, you can state it, you can ask questions about it, they can respond, you can tell them whether they're correct. When they're incorrect, you can give them a hint as to what they did wrong, and you can distinguish between errors that are perhaps rounding errors or clerical errors and those that are more conceptual, and give them a pointer as to where to go. You can also present, if you're dealing with, say, a binomial distribution, you can present the probability distribution, you can present all of the calculations for them so that they don't have to go and look it up in a table. And you can introduce concepts such as acceptance, rejection region, concepts such as power, and how that works. And the question is, how effective is this? So how well does it work? Well, one thing it does, it frees up instructor time and teaching assistant time for tutorial sessions and for additional office hours. So we're able to provide 8 tutorials per week plus 8 office hours per week because we're not grading homework assignments, basically. These students who do well on the students who do well on the homework modules earn higher grades on the tests that we actually give them. So this is just an example of it. So they can get up to 24 marks for the homework modules, and those who keep repeating the modules and do until they get up to 24 do very well in the course. And there's a strong correlation, well, as strong as you can get in some of this kind of research. Just some comments. The modules are very useful. Although it's a program requirement, I feel the structure of the course is maintained to help students do well. The tutorials are important and helpful. The modules are a very good way to ensure that they know things. Amazing organization. Modules are amazing for practice, easy to understand and learn. Modules are a great idea. Have tutorials more applicable to the module assignments. Are you secretly Wolfram? Okay, because they're all based on Mathematica. I'm not Wolfram, I'm sorry, but they're very nice. Overall, the modules are excellent, the TAs are outstanding, and the modules are too time-consuming but helpful. Not everybody likes them, okay? I'm just trying to be honest here. And the modules take a really long time and are expensive and cause a lot of problems. It'd be better to have practice questions can be done on paper. Okay, so there are traditionalists among students as well, and would prefer a paper assignment as over anything else. Okay, so thank you for listening to this story from the trench.